Nip it in the bud.
Just like we always reduce fractions so that we can compare your answer to my answer, they may be the same.
You want a piece of me? You got it!
We always reduce radicals. Now, before I show you how to simplify a radical, there's going to be some prerequisite information you're going to need to know. Remember the perfect squares I told you to get to know? The square root of 4 is 2. The square root of 9 is 3. These are the perfect squares. The square root of 16, 4. Good ones to get to know. The square root of 25 comes out to 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. These are some of the perfect squares.
I'll be back.
And you will be using them when you simplify radicals. Now, don't forget about radicals also. Variables also. The square root of x squared is x. The square root of x to the 4th is x squared.
Now what am I going to do?
Remember about the square root of x to the 6th. Any even exponent with variables is going to come out to be a perfect square. Because remember, you add exponents when you multiply. The square root of x to the 10th is x to the 5th, because x to the 5th times x to the 5th does equal x to the 10th. So any even exponent is going to be a perfect square. You'll need to know that. One other thing. Remember what I mean when I say factors. Factors are numbers that go into another number evenly. These are some of the factors of 12. Okay? Don't mix that up with multiples of a number. These are the multiples of 12. So we're going to be talking about factors also.
And now, ladies and gentlemen, let's get ready to rumble.
Let's talk about simplifying radicals. Much like a fraction is in simplest form when you can't divide the top and bottom by some common number, a radical is said to be in simplest form when the radicand, the number in sign, has no factor that is one of those perfect squares that we just talked about.
Excuse me?
That's the radicand. So for instance, the square root of 24 is not in simplest form because it has a factor that is a perfect square. 4. The square root of 18 is not in simplest form because it has one of those perfect squares as a factor. 9. So you'll need to know those perfect squares. The square root of 10 is in simplest form. His only factors are 2 and 5, and neither of them is a perfect square. So, since he has no factor that is a perfect square root, he is in simplest form. X to the 3rd is not in simplest form because it also has a factor that is a perfect square. Think about it. X squared is a perfect square, and it goes in evenly to x to the 3rd. So the square root of x to the 3rd is not in simplest form. We're going to be using what we call the product rule of radicals to simplify these radicals. Since the word product infers multiplication, I'll bet you the product rule is just what you think it might be. The rule is that the square root of two numbers multiplied equals the square root of one of them times the square root of the other one. For instance, consider the square root of 36.
But that's so easy. I should have thought of it for you.
We know what the square root of 36 is, but we also know that 36 is 9 times 4. So we could break it up into the square root of 9 times the square root of 4. Now the square root of 36 you knew is 6, but it's also the square root of 9, 3, times the square root of 4, 2. It does work all the time.
Allow me to demonstrate.
Now, we're going to use this rule to simplify radicals. This time, I'm going to break 18, or factor 18, into what I will call its perfect squares, you got to know them, and whatever's left over, the garbage left over. Now, the perfect square, the largest perfect square that goes into 18 is 9. That leaves a leftover of 2. Now the reason we took 9 out is that it's a perfect square, and the square root of 9 is 3. And the reason 2 is garbage is because there's nothing you can do with it. So the square root of 18,
Excellent.
simplified, is 3 square root of 2.
Do that again.
Okay, well, basically we're going to do the same thing every time. We're going to break each radical, in this case 75, into the largest perfect square that goes into it times whatever garbage is left over. Now think about it. What's the you got to know your perfect squares. What's the largest perfect square that goes into 75? Well, it's 25. That leaves me, if you divide, with a leftover of 3. Now the square root of 25 is perfect, so I can say that it's 5. And the square root of 3 is garbage left over, so I just write it. And there it is.
Thank you, sir. May I have another?
Now don't let this large number scare you. There may be, or there should be, something. You just keep trying perfect squares until you find one that goes in. I'm going to factor 128 into the largest perfect square that goes into it times whatever's left over after I take that out. And in this case, the largest perfect square is 64. And 128 divided by 64 leaves me with 2. Now the square root of 64 is 8, and the square root of 2 is just the square root of 2. We're doing the same thing every time. You're just going to have to know your perfect squares.
Something's happened to my brain. It's all dried up.
Oh, what about variables? Well, that's the beauty of this. We're going to do the exact same thing. We're going to factor x to the 7th into the largest perfect square that goes into it times whatever's left over. Now, think of your list of perfect squares with variables. Any even number, any even exponent, is a perfect square. The largest even exponent that goes into this is going to be x to the 6th. Now, x to the 6th times what is x to the 7th? Well, that leaves me with x to the 1th, or x. Recall that you add exponents when you multiply. Now, the square root of x to the 6th is x to the 3rd. It's a perfect square. And the leftover, as always, we just write. So this radical simplified is x to the 3rd times the square root of x. How about something like this? Don't let it scare you. We're going to factor it into the largest even, really, the largest even exponent, which is the largest perfect square, times whatever's left over. In this case, the largest perfect square will be a to the 20th, and my leftover will be a to the 1st. The square root of a to the 20th is a to the 10th, and I have my leftover, and there's your answer. This one might take you a little bit more time to do.
Ooh, I'm dying.
Don't let it scare you. Just do it a little bit at a time. I'm going to break it into, of course, the perfect squares and what's left over, but do a little bit at a time. For instance, the 50, I'll break into the largest perfect square that goes into it, 25, and a leftover of 2. The x to the third, I'll break into its largest perfect square, x to the second, and whatever's left over, x to the first. Now, the a to the 6, you need to consider its largest perfect square is a to the 6th. Sometimes they're all perfect, if you would. They're all good, like your mom. Other times, like b, they're like your little sister, all bad, and they go in the scum pile. Okay? So that can happen also. Now, we've divided them out into the perfect squares and the leftovers. Let's take the square root of the perfect square, and I'll get 5x a to the third, and the leftover, as always, I just write. So the simplified version of this is right here.
You just want to be your boss.
How cool is that? Doesn't get any harder than that. Now I need to show you what happens when coefficients are involved, the numbers in front.
Now what am I gonna do?
That 2, since it's a part of the question, is going to be a part of the answer in some fashion. But I'm still going to do the same thing, factor the square root of 125 into its perfect squares and its leftovers. Now, the perfect square that goes into 125 is, I bet you guessed, you're getting good at it now, 25. And the leftover will be 5. Now we can't forget our 2, so we bring him down. Now, the square root of 25 is 5, and the garbage is still square root of 5. But here again, don't forget the 2. Bring him down. Now that that square root of 25 became a 5, another coefficient, a number, the 2 will combine with him multiplicatively.
Excuse me?
The 2 will multiply times the 5, and we'll get a 10. So the 2 gets his say also, and that's your answer. So don't forget to multiply any original coefficient times whatever you take outside the radical. Okay?
Be gone before somebody drops the house on you.
Okay, go do that homework.